Hi and welcome to the Study Hacks. First of all, I will give you an announcement on our online training program, which will be held on the 8th September. And now this registration is the open. So basically, this class will be start from the 8th September. So if you want to join this online training program, you can simply contact with this WhatsApp number, as well as if you want, you can also contact with this email for getting all of this information and also complete your registration. So basically, in this online training program, we are mainly focused only for the beginners who don't have any knowledge about the Google Earth Engine, or who don't have any knowledge about the JavaScript programming or Python programming. So after completing this total 7 days online training program, you are able to do any types of remote sensing analysis very quickly and efficiently using Google Earth Engine platform. Okay, so if you want to join this online training program, you can simply contact in this WhatsApp number and email. So I already provide you all of this information in this video description. You can simply check it, all of this information. And if you want to join, then you can simply contact with me. Okay, so thank you. Okay, so hi and welcome. Can you hear me? Okay, so just we are waiting 1 or 2 minutes for joining other participant, then we will start.
Assalamu alaikum.
Walaikum assalam. Okay, so now we will start our project session. So basically today I will try to discuss about that land use land cover classification using machine learning, such as how we can really implement the land use land cover classification using support vector machine, then classification regression phrase, as well as also random forest or minimum distance. So this type of algorithm how we can easily implement in Google Earth Engine platform, and then make the land use land cover classification map. Okay, so all of those things we try start teach you from the beginners part. So anyone who don't have any knowledge about the machine learning, or anyone who don't have any knowledge about the random forest or as well as also classification trees or support vector machine, don't worry about that. So today's class I will start from the beginners level for the machine learning. Okay, so all of those things we try to discuss step by step. So I hope after completing that you can easily understand the machine learning algorithm, and you can also implement this type of algorithm using the Google Earth Engine platform, and then make the land use land cover classification map. Okay, so let's go our class. I simply share my screen. Okay, so now can you see my screen? Is it visible?
Yes.
So basically, machine learning in art engine. So we can easily implement a lot of machine learning algorithm in art engine platform. Mainly, we can easily implement the supervised, unsupervised, and regression. Okay, so mainly three types of machine learning algorithm we can implement in Google Earth Engine platform. So in this time, I will show you only for the supervised and unsupervised. Okay, so regression is our another advanced online training program for the regression. So I show you that how we can easily implement the supervised classification method and also unsupervised classification method. Okay, so two types I will try to discuss, and also try to discuss about the all of those supervised machine learning algorithm, and also mainly unsupervised talk about the clustering, how we can easily implement the clustering and also make the classification. Okay, so first of all, supervised classification or supervised machine learning. So supervised machine learning, it's one of machine learning technique for classifying land, is to use ground truth example to teach a model to differentiate between classes. Okay, so mainly when you want to do the supervised classification, first of all, you have to take the ground truth data. Okay, you have to collect the ground truth data as a training point. So when you want to do for the supervised classification model, you must need the training point. Okay, and what is the unsupervised classification? So mainly unsupervised classification, when you do, you don't need to take any types of ground truth data or training data. Okay, so mainly supervised, you must be need the ground truth data, mainly training point, and unsupervised, you don't need to any types of ground truth data. Okay, so in this time we talk about the both of things and how it will be work for the different types of algorithm in Google Earth Engine platform, and then how we can easily work with that supervised and unsupervised. So just to supervised algorithm, when you want to do, you must need the ground truth data or training data, but unsupervised don't need any types of ground truth data or training data, or pre-categorized data don't need for the unsupervised classification. And regression, it is the another types of suppose regression model could predict, suppose when you want to predict anything, suppose water quality, presence of forest cover, presence of cloud cover of proof yield. So this type of we can do easily use in regression, such as linear regression we can easily use in Google Earth Engine platform and identify where is the trend of the vegetation. Suppose for the Dhaka city, which region is the low trend of the vegetation, what is the high trend of the vegetation. So this type of work we can do using the regression model. Okay, so in this time, first of all, we should know about the classifier. Okay, so mainly what is the classifier? So classifier, it is a classification. Suppose the algorithm which implement the classification on a data set is known as a classifier. Suppose for the classifier, suppose I have a data set. So now this data set I want to implement an algorithm, this type of algorithm called the classifier. In this time, for the supervised machine learning method, we can use a lot of classifier, such as random forest, such as support vector machine, such as classification regression trace. So this type of classifier, as well also minimum distance trace. So this type of classifier we need to use. Mainly this classifier, it's an algorithm that implement the classification on data set. Okay, so it is a classifier. And mainly primary, we can get the two types of classification. One is the binary, and that is the multi-class classifier. So one is the binary. So binary, if the classification problem has only two possible outcome, okay, it's called the binary. Okay, suppose support vector machine is a binary classifier. So binary means that it has only possible outcome will be only for the two. Suppose yes or no, male or female, spam or not spam, cat or dog. Suppose forest, deforestation. So this type of example for the binary classifier, which have only outcome, possible outcome only for the two outcome we can get from here. Okay, and multi-class classifier. What is the multi-class? So multi-class classification problem has more than two outcome. So more than two outcome, then it's called the multi-class. Suppose it can be land use land cover classification. So when I do the land use land cover classification, here I can get the more than two outcomes, such as forest, vegetation, land use, also water body, build up area, more. Suppose you want to classification of the types of crop, so we can get the different types of crops, sugar cane, maize, rice, a lot of crop we can easily classify. Or also suppose classification of the types of music. Okay, so mainly classifier, this classification type, two type, binary and multi. So this two type classifier, we are use the different types of algorithm. It's called the classifier. So this type of algorithm called the classifier. So first of all, I try to discuss about that all of those classifier and how it will be work. What is the main algorithm about this classifier? Then we show you the practical example. So let's go. Further, I simply open my another slide. So first of all, what is machine learning? So machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and algorithm to imitate the way that humans learn and gradually improving its accuracy. And machine learning method, so mainly supervised machine learning method and also unsupervised machine learning method. Okay, they are the two types of main, and also reinforcement is also another method, but in this time we just talk about the supervised and unsupervised. Supervised machine learning method must need the training point, and unsupervised machine learning method don't need any types of training point. So now we can see the classification about the supervised and unsupervised. So supervised learning, it is a pre-categorized data, must pre-categorized data. And unsupervised learning don't need any types of pre-categorized data. It totally unlabeled data. Okay, and supervised learning we are used for the two types. Supervised learning we are used for the classification and also used for the regression. Okay, regression means that forecasting. Okay, and classification means that suppose identify any specific properties or a specific property or a specific things. Okay, and now you can see here the unsupervised learning we can do for the clustering, association, and dimensionality reduction. So in this time I just only for the talk about the clustering. Okay, so these two things in this time I not talk about in this training, I just talk about the clustering. Okay, so what is the clustering algorithm? Clustering algorithm mainly find out the similarity. Okay, find out the similarity. Suppose when I apply the clustering model, suppose I have a data set satellite image about the Dhaka city. So Dhaka city, suppose water pixel value, build up pixel value, then also suppose vegetation pixel value is not same. Okay, so it's a different. So when I apply the clustering, it's find out the similar class of pixel value. Suppose all of those water pixel value create the similarity and make the clustering and create the water body. All of those urban pixel value make the similarity and make the urban area. Okay, so when I show the practically, then it's better. So in this time clustering is mainly work for the similarity. Okay, all of the similar object or similar pixel value combination. Okay, and classification is mainly for the supervised learning. Classification we do for the classified for any specific properties or any specific feature, and regression mainly the forecasting, different types of forecasting when you do about that regression model. So let's go further. So supervised learning is that the classifier package handle the supervised classification by traditional machine learning algorithm running in Earth Engine. In this time, in Google Earth Engine platform has already some package. Okay, in Google Earth Engine platform already input some package for the supervised classification, and this classifier include the cart means that classification and regression trees, random forest, Navier bias, and support vector machine. Okay, SVM algorithm. If this type of package or this type of classifier already available in the Earth Engine platform. So now you can see, first of all, the general workflow for the classification. When you want to do for the classification, so this is the general workflow. So first of all, it is a supervised. So it is a supervised. That's why you must be collect the training data all time. For the supervised, first of all, we need to collect the training data. Okay. After that, we need to input a take a classifier. In this time, if you want, you can use that support vector. If you want, you can use that a support classification regression trees or any types of classifier you can take. After that, train the classifier using the training data. Then classify an image or feature collection classifier, and then estimate the classification error. So mainly it's the check the accuracy about that. So now this is the workflow. First of all, you can collect the training point. Okay. After that, you can choose a classifier and then train the classifier using your training data, and then classify this image and then check about the accuracy. What is the accuracy of your map, land use land cover map, or what is the validation? You can check it, the accuracy. So now we talk about the support vector machine. So support vector machine, how it will work for this algorithm. So support vector machine or SVM is one of the most popular supervised learning algorithm, which is used to classification, as well as we can also use it for regression problem also. So support vector machine is supported the two things, classification as well as also regression problem. And support vector machine is one of the most popular supervised learning, which classified the regression problem as well as also classified about the classification problem. We already talk about that. So now what is the main goal of the support vector machine? Okay, support vector machine algorithm, its main goal is that to create the best line of decision boundary. Okay, so it create the best line of decision boundary that can segregate n dimensional space into class, so that we can easily put the new data input in the correct category in the future. The best decision boundary is called the hyperplane. Okay, so I show you the figure, then it's better. So you can see in this time, it's a figure about the support vector machine. So in this time, suppose in this time, this type of, you can see, suppose this is the pixel value. Suppose you can simply, this pixel value is for the suppose vegetation, and this pixel value for that, suppose it's a water body. Okay, so this is the data. Okay, and this type of pixel value, this type of data called the support vector. In the support vector example, it's create the baseline between the two pixel value, two different pixel value. It create the one baseline. Okay, so it's the main target about that, and its baseline called the maximum margin hyperplane. Okay, and in this time you can see this pixel value, which pixel value is near to the baseline, it accept it is a water or it is a blue. So in this time we can get the baseline, this is the baseline, and we can get the support vectors, support vector for that vegetation, and also get the support vector for that, suppose it is a water body. So now which point, suppose water body, which point is the near to the baseline? Suppose in this time this algorithm find out the it's the near to the vegetation. Okay, this is the baseline, it's near to this vegetation point. So then it choose it is a pixel value of vegetation and make this algorithm and display the result as a vegetation. Okay, support vector machine can be two types. We can get the two types of support vector machine. One is the linear and another is the non-linear. So mainly in this time we talk about the linear support vector machine. So basically linear support vector machine is used for linearly separable data, which means if a dataset can be classified into two classes by using a single or straight line. Suppose linear, suppose when you want to classify only for the two things. Suppose I classified forest and deforestation. Suppose you want to only for the two class, forest and deforestation. So it's only for the two classes by using a single straight line. A straight line means that this straight line. Okay, this straight line, I divided the two data sets, suppose forest and deforestation. Okay, two classes. So it's called the linear support vector machine algorithm. So linear support vector machine, it's mainly used for when you can do the classified into two classes by using a single straight line. And non-linear is that it's separate, which means if the dataset cannot be classified by using a straight line, that such the data is the non-linear. Okay, which I cannot classify using a straight line. It's a non-linear. Suppose there are a lot of pixel value, and I did not create about this type of hyperplane. I did not create for the, suppose in this time there are a lot of other types of pixel value also available. So that's why support vector machine is work well when you want to classify only for the two classes. Suppose you want to classify it only for the two class, then support vector machine is work well. So that's why when we are doing for the forest and deforestation, this type of classification, all time we are using at the support vector machine algorithm for that classified the forest and non-forest region. So it's also better when you want to classify the two classes, any two class you can classify, there is no problem. Suppose you classified the water body or build up area, use the support vector machine. But when you want to apply the more classes, more than two classes, then we have to choose the other algorithm. It can be a random forest or it can be a classification region trees. Okay, I also talk about the later about this. So in this time, linear support vector machine, it's mainly work well when you want to get the data set and classify it only for the two class. And we can get the better result about that for that. So in this time here you can see it's showing the maximized margin about that. And also we can get the, yeah, please.
When do we use a non-linear support vector machine?
Non-linear support vector machine we have to use when you want to so basically non-linear is not better for the classification. Okay, so suppose when you want to work with for the other data set, not only for the remote sensing part, then non-linear is work well. Okay, but for the classification purpose, linear support vector machine is the better for the classified the two classes. Okay, but suppose when you want to do for the other data set, it's not mean about that, suppose satellite imagery or classification, then you can also use the non-linear. Suppose it's only about that suppose tabular data, suppose in your Excel file lot of data set in available in here, then you can easily apply it. But for the classification, image classification or satellite image classification, and when you want to do for the two class, only for the two class, then this support vector machine is work well. Okay, but non-linear has the another part about that, but only for the two class classification is work well for that support vector machine, and it's called the linear. And in Google Earth Engine platform, it's only available for the linear part. For the support vector machine is only available for the linear part. Okay. Okay. So now here you can see the another picture in here. So we can get, so mainly this type of data or this type of pixel value called the support vector. Okay, and it's our maximum line. Okay, maximized margin, we can get, this is a maximum margin about that, and it's the distance. Okay, from this point and this point is the distance. Suppose this point and this point is also distance. Okay, and it's called the optimal hyperplane. Okay, and support vector machine is the main target is that it creates the optimal hyperplane between the two data set. In this time, this is the blue color and green color. It creates the maximum margin line. And there is a lot of application. So support vector machine will help to find out the best line or decision tree boundary. The best boundary region is called the hyperplane. Okay, and the support vector machine algorithm find out the closest point. Suppose it find out the closest point to the lines from the both of classes. Okay, and these points are called the support vector, and the distance between the vector, basically this is the vector, it's called the support vector, and the distance between the vector and the hyperplane is called the margin. Okay, and the goal of the support vector machine is maximize the margin. The hyperplane with maximum margin is called the optimal hyperplane. Okay, so I also send you all of the slides, so you also try to study, then you can easily get understand all those things. So support vector classifications has some argument. In Google Earth Engine platform, we find out some argument such as decision procedure, support vector machine type, kernel type, then shrinking, then degree, then gamma, then cost, then NU. Okay, in this time we talk about that support vision classification algorithm. First of all, decision procedure. Okay, so decision procedure to use for classification, either voting or margin. Okay, and not used for the regression. Decision procedure, it's not used for the regression. It's only for the classification. You have to use the voting or margin. So now, what is the voting and what is the margin? I talk later about that. So first of all, in this time support vector type. So basically in this time, the support vector type we can use only for the linear type. Linear type, and it's these different types of linear type. You can see CSVC, NUCVC, one class, okay, NUSVR. So if this type of is the type, and all of those type including the linear and kernel type. So kernel type is one of the linear. You can see in this time kernel type linear is this is the linear. We can also poly. Okay, this is the equation. So basically this type of equation already built in Google Earth Engine platform. Just suppose when I use the linear means that this type of equation. RBF means that this type of equation. Sigmoid, this means that this is the equation of the sigmoid. But this equation is already built in Google Earth Engine package or Google Earth Engine support vector machine package. So just in this time, suppose when I use here the RBF, then it calculated using this equation. When I use the sigmoid, then it calculated using this equation. When I use here the poly, then it calculated using this equation. Okay, so this type of equation is already stored in the package. So in this time, I don't need to use any types of equation. Just I simply select my kernel type, linear or poly or RBF or sigmoid. We sign it, just simply select about that. So in this time, popular kernel type. So basically, support vector machine popular kernel type. It's called that about the polynomial kernel, and also called the also Gaussian kernel, radial basis function (RBF). Okay, so all of those things is the popular kernel type. So basically, we are using at this kernel type, radial basis function or RBF. It's very popular. We are use this kernel type and classification all time about that. As well, also you can get this type of kernel type, segment kernel type. Okay, this type of kernel type is also available for the support vector machine. And polynomial kernel type you can see. So in machine learning, the polynomial kernel is a kernel function commonly used to the support vector machine and other kernelist math models that represent the similarity of vector. Okay, from the training sample and find out the similarity of vectors in a feature space about the polynomial and of the original variables, allowing the learning of nonlinear models. So in this time, radial basis function RBF, it's a popular kernel. So basically, in this time, RBF when we need. Okay, so RBF kernel are the most generalized from the kernelization and is one of the most widely used kernel due to its the similarity to the Gaussian distribution. And the RBF kernel function for the 2 point x1 and x2 compute the similarity and or how close they are to each other. Okay, so RBF function, so mainly suppose you have the 2 point x1 and x2, compute the similarity between the x1 and x2 and how they close they are to each other. And this kernel can be mathematically expressed as follow. So this is the equation about that kernel type. Okay, so in this time, x1 and x2 is the different 2 point. Means that suppose x1 is that suppose the vegetation pixel value or x2 is that water pixel value. So now this RBF kernel function compute the similarity between the 2 point and how close they are to each other. It is the RBF or radial basis function work for that. And this is the main equation about that RBF when you want to work for the 2 point or 2 pixel value. Okay. So now we talk about the gamma. So gamma, in this time, gamma is the 2 type, high gamma and low gamma. This is our baseline. Okay, this is our baseline. And suppose this type of classification pixel value. Okay, this type of classification pixel value. When this distance, we can get in this time, you can see we can get the low low distance. Okay, low distance, low distance, low distance. When I can get the low distance, it means that it's the high gamma. Okay, and then when we can get the distance is long distance, so then we can get the low gamma. So high gamma means that our decision, our maximum of hyperplane from this point and this point is the low distance. Okay, when it will be low distance, then we can get the high gamma, and when I can get the high distance between this line, straight line, I can get the high distance. It called the low gamma. And this is the equation about the cost function. So basically this is the cost function equation. So this type of equation is already built in support vector machine in Google Earth Engine package. So that's why in this time we are not talk about in here. Just this is the equation how it will work. So it's called the cost function, and cost function is used to train the support vector machine by minimize the value of the theta. Okay, this value we can ensure that the SVM is the accurate as possible in the equation. The equation cost 1 is that cost 0 refer to the cost for an example where y is equal to 1, and the cost for the example y is equal to 0. For the SVM, is cost is determined by the kernel similarity function, and this is our cost function equation, main equation. And from that we can simply, in this time this equation I did not memorize anything about that, just I simply set the theta value. Okay, then it will be work using this function. Okay. So now we show you the practical example about that. Suppose here you can see the classifier. In this time classifier we are using here the support vector machine, and use here the kernel type is the RBF, radial basis function, and gamma use here the 0.5. It means that 0.5 means that our decision boundary or maximum decision boundary from our vector distance 0.5, and cost is the 10. 10 means that in this time here I put the theta value is the 10. Okay, theta value is the 10. And then classified the two classes. One is that it's showing that forest, and another showing is the deforestation region. Forest and deforestation region. Okay, so this is the example about that support vector machine. Okay, and I will send you all of those practice code after describe about that. So this is a support vector machine. Okay, so basically it work this process. For that all of those argument we need to know about the gamma, then radial basis function, then cost function we also need, and different types of kernel. Okay, and support vector machine. Okay, so basically its main target is that it create the boundary line, it create the line which is the closest from the different pixel value. Okay, so now I talk about the another algorithm, such as suppose and now we talk about the card classification. Okay, just a minute. So classification and regression trees, it's called the card classification in Google Earth Engine platform, classification and regression trees. So classification and regression trees is also called the card, is a predictive algorithm used in machine learning to explain how target variables values can be predicted based on other values. Okay, so it's defined on the other values for predicted the target variable. Okay, and then it is a decision tree where each fork is split a predictor variable and each node. And what is the node? Node is the final output of the from the decision tree. At the end has the prediction for the target variables. And the card algorithm is important for the decision tree algorithm that lies at the foundation of machine learning. Okay, and moreover it also basis for the other powerful machine learning algorithm and such as random forest. We also need to use the decision tree. Okay, for the random forest is also available for the decision tree, all boosted decision trees. So mainly in this time we just talk about the random forest, and random forest has also need the decision tree. Okay, and what is the decision tree about that? So card for the short is that introduced by the Leo Berman. So he discovered this this algorithm for the card. to differ the decision tree algorithm that can be used for classification and also used for the regression for predictive modeling problem. Okay, so cart is mainly work for the two things, classification and regression, and the cart algorithm provide the foundation for the other algorithm such as random forest or boosted decision trees or decision trees. It also foundation of other algorithm. And cart model representation. So cart model representation for the cart model is the binary tree. Okay, so what is the binary tree? We already discussed about the binary tree, two types of binary classification. Okay, so binary is that mainly two result, two outcome I can get from here, yes or no, or also forest deforest, also spam not spam. So this type of only for the two outcome when I can get from here, it's called the binary. And in this time card classification model is a binary tree. So in this time here you can see, suppose in this time I put a condition look like that. Suppose height greater than 180 centimeter, if it yes or no. So if it will be yes, then it will be male, or if when I can get the result no, then it also check the weight. Weight, suppose weight greater than 80 kg. Then if the yes, then it find out the male, or if the no, then it will be male, female. Okay. Suppose in this time, this is my condition. Okay. So using this condition, I just find out, I just classify male or female. Okay, so height greater than 180 centimeter, if the question answer is the yes, or if it will be true, then I can get the result is the yes. And when it will be yes, then I can classify this is the male. And suppose it will be no, then it will check the other condition. Other condition means that in this time it check the weight. Suppose weight greater than 80 kg. If it will be yes, then it will be male, and no, it will be female. So basically, this is the condition about that. Okay, I take the another example. In here, you can see. Suppose cart model representation. Suppose in this time, you can check about this figure. And here you can see, if the height greater than 180 centimeter, then it will be male. Okay. And if the height less than equal 180 centimeter and weight greater than 80 kg, then male. Okay, and if the height greater than less than equal 180 centimeter and weight is the less than equal 80 kg, then female. Okay, so in this time from this figure and also given the information, when I put input, suppose this is my condition or this is my condition. In this condition, I just simply input height 160 centimeter and weight 65 kg. So now question, it will be male or female?
Female.
So anyone can guess it? What is it in this time? It will be male or female using this
Female.
condition. Okay, so it
Female.
will be, yeah, it will be female. Okay, so in this time what happened, you can see in this time it check it about the height is that when height greater than 180 centimeter, we can get the no. Okay, and also weight greater than 80 kg, we can also no. So therefore it will be female. Okay, so you can also check about that. So mainly cart is working look like that. Okay, suppose I take the pixel value and then it check this pixel value is the water. For water, yes. For suppose other class, I take example. Suppose in this time classification using cart model, you can see. Suppose in this time you can get here, I can get the 3 pixel value, such as you can see this is a point about the 0.4, 0.3. So in this time, this suppose this is the green and this is the red color and also this is the blue color. So all types about the pixel value. In this time, suppose this red is the build-up area and it's suppose it's that water body, and suppose it is that for vegetation. Okay, so 0.3, when it will be greater than 0.3, it will be green or vegetation. And also you can in this time, suppose I take this, suppose red greater than 0.4. Okay, red greater than 0.4. Then what? Suppose yes or no. Two question I can. If it will be yes, then it will be building or build up area, because 0.4 all of this will be build up area. If when this condition is true, suppose rate is a greater than 0.4, then it will be building. Okay, and if there is the no, then what happened? Then it will be vegetation. Okay, and further I also check about the another condition for the vegetation. Green greater than 0.3, then suppose if the true, then what happened? Well, then it will be or no, then what happened? So when it will be greater than green 0.3 greater than, then it will be vegetation, and then it will be no, then it will be water body. Okay, so basically card classification work for this method. Okay, first of all, it take the pixel value and check about the yes and no, and if there I can get the no, then it also check. So in this time here I can get the no. For that, it also check about the vegetation parameter, such as also more classes or a lot of pixel value about that. So in this time we can take only for the 3 class, so that's why you can get this water, build up and vegetation. But when you will be work the more class, then it also more check. Okay, all time it check. When I can get the no, it also check about this result and take this pixel and check the result about that. Okay, so in this time the classification regression trees has also some argument. Okay, so this argument called the max node and mean leaf population. So first of all, what is the max node? Max node is the maximum number of leaf node in each tree. So tree means that suppose it's a tree, it is tree. Okay, so it's a tree. In this time, max node is the maximum number of leaf node. So now question, what is the leaf node? Suppose in this time, what is the leaf node? How many leaf node I can get in here? Leaf node is that it is the final result. Okay, suppose in this time here I can get the final result building. Okay, suppose this is a building. There is a no confusion. There is the no doubt about the building or not other things. There is a no doubt. It is a building. So it's my final node. So it's my final node. And also you can see I can get the vegetation. I can get the vegetation. So it's also my final node. Okay. So what is the final node? Leaf node is that, sorry, it is the leaf node. So it's the leaf node. Okay. Leaf node is that which I cannot distribute it again. Okay. Suppose in this time here I can get the building. This is my fixed result. Okay. So leaf node is the final outcome. Okay. In this time max node is the maximum number of leaf node in each tree. And if the unexpected default to no limit. Okay, so max node is that number of leaf node, and what is the leaf node? Leaf node is the final output. And mean leaf population. Mean leaf population is the only create the node which training set contains the at least this many point. Okay, create the node and which have the training set contain at least this many points. So mean leaf population is the combination of the suppose lot of training point, this type of things. So basically you can get the two types of argument for the classification regression trees. One maximum we are using here the max node, and mean leaf population is the not need, but max node is that final output, how much final output I can get from here, this value. And what is the leaf node? Again I talk about that. So in this time you can see, first of all, it is a tree. Okay, in this tree you can see this type of, suppose this tree decision tree. So I can classify it into decision tree, also decision tree. In this time you can see also decision tree. So in this time this leaf node is not distributed again. Okay, it's not a make the tree again. So it is the final output. Okay, there is the no sub tree. You can see there is a no sub tree. So in this time 1, 2, 3, 4, 5. Here I can get total 5 leaf node. Okay, so total 5 leaf node I can get. Leaf node is that which I cannot distribute it and which cannot create any subtree. Suppose in this time it's not a leaf node because it create the subtree. It's also not leaf node because it create the subtree. You can see from this decision node I can get the 2 decision in here, but from here I can say I did not get the only for the 2 leaf node, but it also not create any types of subtree. So that's why it is a leaf node. Leaf node is the final outcome from a decision tree. And which first one it called the root node. Okay, so in this time there's the first, this tree will be start from here, it's called the root node, and it's also called the subtree, and this type of final output called the leaf node. And in this tree, how much leaf node we can get? We can get total 5 leaf node. Okay, so in this time I talk about that. So basically it will be work look like that. So classification regression trees. So first of all, what suppose this there's a lot of pixel will I can set in here, but when I apply the classification trees, then it will be checked. Okay, this type of yes or no, yes and no, and check one by one, and classified our land use land cover classification map. Okay, okay. So now I talk about the random forest, how it will be work. Just a simple open. So random forest is mainly working for the majority voting. Okay, so majority voting, suppose I can get the 5 pixel value for water, 2 pixel value for that vegetation, 3 pixel value for the suppose barrel length. So it take the majority voting 5 pixel. Okay, and then make the classified. Okay, so let's go about the random forest. So random forest is a supervised learning algorithm. Basically, random forest, classification agent trace, support vector machine. The 3 algorithm is the totally supervised machine learning method. Okay, and when you want to do for the supervised machine learning method, you must take the training point. You can apply the any algorithm. It can be random forest, also support vector machine, and you can also apply here that classification agent trace. Anything you can use, but it's a supervised machine learning method. So that's why all time you can take the training point. Okay, so then random forest is a classifier that contains a number of decision tree. Okay, so it's a contains a number of decision trees on various subset of the given data set and takes the average to improve the predictive accuracy of that data set. So in this time we also get the concept about the decision tree. Okay, and decision tree is it's come from that classification and regression trees. From that it come decision tree. Okay, and the so that's why card classification is also called the foundation of random forest. And the forest is the builds is the assemble of decision tree usually trained with the bagging method. The general idea of the bagging method is that a combination of learning model increase the overall result. So how does the work for the random forest algorithm? So random forest algorithm work in 2 phases. First, it to create the random forest by combining of n dimension tree, and second is take the prediction of each tree and create the first phase. Okay, so mainly random forest work for the 2 phase. One phase, first of all, is the combining of number of decision trees, and second to make the prediction for each tree and create the first phase. First of all, first step, select the random data or select the random point from the training set, and then build the decision associated with the selected data points, and then choose the number of n or number and decision tree that you want to build, and then simply repeat step 1 and step 2, and then finally for new data point and find out the prediction of each decision tree and assign the new data point to categorize that wins the majority voting. Okay, so in this time we talk about the example. So in this time here you can see, suppose in this time we have you can get the some fruit look like that. Okay, so from this fruit it create the decision tree. So in this time it called the decision tree 1, 2 and 3 number decision tree. And if how much decision tree create, it depend on our data set. Okay, suppose if your data set is the big, then it creates a lot of data set. So that's why it create the tree n. Okay, n number of data set. Okay, 1 2 3 4 5 6 7 n number of data set. Okay, so in this time, suppose this is my different types of fruit in here. So now here I apply the random forest. So how it will be work? So first of all, it take a one fruit. Okay, it take a one fruit in here. Okay, then check it. It will be tree. It will be apple or banana or other types of fruit. Then it will be yes, and then yes. Suppose it check another time no. Then you have to check what is that. And this type of analysis work. And finally, when I did get the leaf node or final output, then it will be okay. So in this time from here, suppose from this decision tree, I can get the result, suppose apple. Okay, and from this decision tree I can also get the apple, and from this decision tree I can get the banana. Okay, so now from this tree 1, tree 2, or n number of tree, I need to find out the majority voting. Which fruit is major, then I select that. So in this time you can see here I get the two time I can get the apple. So that's why my final class will be apple. Okay, so it first of all, after completing the decision tree, it apply the majority voting and then select the specific class. Okay, suppose in this time here I can get the lot of pixel value for the water. Suppose I can get the water, and suppose vegetation. Then majority voting will be water, because I can get the two time I can get the water. So then I can get the majority voting will be water. So in this time application of random forest, so mainly there is a lot of application for the other sector also, for the banking, then medicine, then land use, land cover. We can identify the areas of similar land use by this algorithm, and also use for the marketing. Okay, all of the sector we can easily apply the random forest algorithm. So advantage of random forest. So random forest is the capable of performing the classification as well as the regression. So this is another advantage of using the random forest, and it's capable of the handling the large data set with high dimensionality. We can use the any lot of big data set. We can easily use it, and it enhances the accuracy of the model and prevents the overfitting issue. So in this time we take the practical example, random forest example. Suppose in this time new pixel value. Suppose this pixel value I don't know what is that. It will be water or vegetation, I don't know. So in this time I take the new pixel value. In this pixel value I can set some decision tree for checking what is that. It will be water or it will be forest. So I create the one decision tree, also get the another decision tree, and also get the another decision tree. So I create the total 3 decision tree. So in this time here I can get the vegetation. Suppose final I can get the vegetation from this tree, and also get the water, and also get the vegetation. So in this time majority voting I can get the vegetation. Okay, so now my new pixel will be vegetation. Okay, so it take the one pixel and then check using the decision tree. Okay, so decision tree is the binary. It check the what is that. Okay, and then find out when I can get that, it will be showing the majority voting. So in this time here I can get the majority voting is the vegetation, and I can get the result of the vegetation. Okay, and it has also some argument such as number of trees. Mainly number of trees, the number of decision tree to create, number of decision tree, and what is the decision tree. So in this time how much decision tree in here, there are the total 3 decision tree. Suppose it is a one tree, it's also another tree, and it also one another tree. So total 3 tree. Okay, so first of all, first argument you can see number of trees, the number of decision tree to create, how much decision tree you can put. It is a one number argument for this function. So the number of decision trees, and then basically the number of decision trees should be have the 64 to 180 128 trees. Okay, we are using for this number, between this number. So 150 between this number we can get the better result. Okay, some scientists or some paper you can also check for the scientific paper, they are all time they are using the number within the 64 to 128 trees, but it's not a fixed. Okay, so this is a number of trees, and the number of trees is that decision tree, how many decision tree you want to put in here. Okay, so this is the random forest algorithm. So mainly 2 argument in here, and how it will be worked. So I hope you can easily understand about that from this slide. Okay, so now any question about the 3 argument or 3 classifier, random forest, classification trees, and also support vector machine. Anyone any question you can ask me. Okay, so this is an algorithm. Basically first of all you talk about the theoretical part, then show you the practically how it will work. Okay, so anyone any question you can ask me about that. Any question? And I also send you the reference book also about that, so then it's also better for the study about the machine learning, and also study about the, all of this algorithm, then you can easily understand about that. Okay, so any question? Okay, so now we talk about the practical example, then it's better. So let's go. Okay, so in this time we jump on just classification on Google Earth Engine platform. So we already know about the supervised, unsupervised, and also talk about the supervised classification algorithm. Mainly three algorithms we can talk: support vector machine, classification trees, and also talk about that random forest. Okay, the three algorithm we talk about that for the supervised and unsupervised, mainly clustering, only for the one classifier clustering. Just we need to do the clustering, and then it will be work. There is no problem. Okay. So now, what's the process to make the land cover classification map using Google Earth Engine platform? Any kind of supervised. Suppose you want to apply the random forest, you can apply the classification in trees, you can apply the support vector machine. Any algorithm you can apply, but our process all time will be same. Okay. Suppose this process you can also apply the any types of algorithm for supervised. Okay. So first of all, you have to selecting your ROI. Suppose you can selecting your ROI, your region of interest. Suppose you want to work for the Dhaka city, simply import the boundary shape file of Dhaka city. Okay. So first of all, you can simply select the region of interest of Dhaka city or your specific boundary, which area you want to create the land use land cover classification map. After that, simply choosing and filtering the image collection. You can choose the Lancet or Sentinel, or you can simply choose and then filter this image collection. Okay, this is a second step. And then collecting the training point. In this time, we need to use the supervised. So that's why must be collect the training point. Without it's not for the supervised. Okay, so you must collect the supervised machine learning algorithm. And then we also merge the training point. Okay, so after collecting the training point, I need to merge all of those training point together. And from this training point, I extract the spectral signature or spectral or band pixel value. Okay, I extract the band pixel value from all of those training point. Okay, suppose water body, I extract the pixel value. For forest, I take extract the pixel value, or build up way, I extract the pixel value. So all of those training point, from this training point, I just extract the pixel value. And then create the classifier. In this time, create the classifier. In this time, if you want, you can use that the random forest. If you want, you can use that support vector machine, or if you want, you can use that the classification action trees. Anything, any classifier you can use, and then classify the image, and then create that classified image, and this display the result for your land use land cover classification map. And then you also need to calculate the error matrix. Error matrix mainly means that in this time we just find out the make the confusion matrix. Okay, from the error matrix we calculate the confusion matrix, and then for our accuracy assessment for confusion matrix. And when I can get the confusion matrix, then from this confusion matrix we can easily calculate any types of accuracy, kappa accuracy, as well also calculate the overall accuracy, then producer accuracy, consumer accuracy, all types of accuracy we can easily calculate from the confusion matrix table. And then we will need to calculate the area for each class, how much class is available for that. Okay, so let's go. So first of all, I just simply open my code editor and show you the practically all of those things one by one. So now continue. So first of all, I just simply import my boundary area, which as a ROI. Okay, put the way around. So now I display the result. So you had the map dot add layer and use at the RY, and also focus the center of the shapefile. So use at the map dot center object, and object is that RY, and click to run. So now it displays the my study area. Suppose this is my study area. So for this study area, I want to create my land use land cover classification map. Okay. So now from here, in this time, my first steps are done. Then second step. Second step is that choosing and filtering the image collection. Okay. So in this time, second step, which image collection you need to use. You can use any image collection. There is no problem. All of those image collection same. Lancet, Sentinel, both of images is the same approach. Okay. Suppose in this time I work for the Lancet image. So click on the browse data catalog and go to the image collection of Lancet. Click on the Lancet. That I just simply find out, suppose Lancet 8. I want to work for that surface reflectance imagery. So in this time, simply copy this art engine snippet from here. Just filtering the image collection and display the Lancet 8 imagery. Okay, we already discussed about a lot of time about this code. Just take a variable. Suppose I put the variable as the image. Okay. Okay. So further, this image collection I just need to filter according to the where, how, and when. So in this time, use at the filter bounds function and put here that RY and put here the filter metadata. Thus, as I put here this cloud cover less than 1, and also put here this, suppose filter date function. Suppose I need to create the map for land use and government for year of 2020, 1st January from year of 2020 December 31. Okay, in this time I create the median composite. If you want, you can take the single image and work with that. In this time I create the median composite. Okay, just use that the median and then click with my shape file.
Excuse me.
Yeah, please.
If suppose you said like here you will use the median composite. Let's say I may use a single day image. Okay.
Yeah.
And if that single day image is not covering the entire boundary, let's say I need to take 2 days of image.
Yeah.
So in that case, how will I clip the area?
Okay, then we need to use the median composite. Okay. Suppose you want to, suppose basically it will be when you want to work the big region. Suppose big region is not possible to one tiles is not covered. Okay.
Okay.
Then we need to make the combination of images. Okay. Then
So for big areas, it is always better to use median composite.
yeah, for the big region. Okay. Suppose when you want to work with for the full country boundary of Bangladesh, so for that one single tiles is not possible. Then we can easily use the median, and then but for the small region, suppose Dhaka city, we can easily find out the one tiles is the fully cover my region. Then we can easily use it. There is no problem.
So that means like if my area is not falling under one tiles, more
Yeah.
than one tiles, so it is always better to use median composite.
Yes.
Okay, thank you.
Yes. So now I display the result. So click to the run. Okay. So it's showing the black color. Just I set the visualization. Just as red, green, and blue. 98%. Apply. And also import that. Simply copy this variable name and paste after the object name. Okay. So this is my second step for choosing and filtering the image collection. So in this time, I can get the image collection look like that. for the Dhaka city, year of 2020. So now from this image collection, I just need to collect some training point. Okay. So in this time, we are not going to the field and take the training point. In this time, we are using the different types of band combination and then collect the training point. Okay. So basically, we are using the different types of band combination for identify the different types of feature on the surface using the remote sensing. Suppose true colors, false color, agriculture combination. So there are a lot of band combination is available in remote sensing. We are using the different types of band combination and find out our target feature. And from that, we just collect the training point. In this time, it's showing the band combination is that red, green, and blue. Red, green, and blue. So then I can get the result look like that. You can see. I can get the water body look like that. I can get the urban or build up area look like that. I can get the vegetation as a natural color vegetation, this type of color. Okay, green color. Okay, we are also get the barren land, this type of color. Okay, it was the barren land with this type of color I can get. Okay, but when I use the another band combination, suppose I put here that near infrared, then red, suppose green, and also customize 98% and apply. So now we can get the result. Water body will be black color. Okay. So in this time you can see water body will be black color. This is the water body, black color. Okay, black color. And we can get the vegetation as the red color. Okay. So better vegetation has a better red color. Okay. You can see deep red color. So this is a deep vegetation or dense vegetation. Okay. The red color. Okay. So 543 near infrared, red and green. When you are use this band combination, then we can find out the water body will be black color or dark color, and vegetation will be this type of red color. Okay, bright red. It's the dense vegetation, bright red. Okay, as well as we are also used another such as this band combination such as short wave infrared one, then put here that near infrared and blue, and then apply. In this time I can get this another band combination. So mainly it's useful for identify the agricultural land as well as also barren land or fallow land. In this time we can get this type of gray color as a fallow land. You can see fallow land, gray color. This type of color we can get as a fallow land. And in this time we also identify the wetland also. In this type of land is the wetland. Okay. So mainly this type, this band combination, short wave infrared one, near infrared, and also blue. When I use that, then I can easily find out the agricultural land or vegetation and also fallow land and also wetland. Okay, this is the wetland we can easily identify in here. Okay, so this is the I can see this is that this time is that barren land or fallow land, and wetland just we can get this type of color. Okay.
We know which one is agriculture.
Okay, so agriculture mainly in this time, agriculture we can get the better green color with also the structure. A structure means that it will be has a shape. Suppose a square shape or rectangle shape. Okay, a square shape, rectangle shape, we can get that. So in this time, when I zoom it, so for this region there is a not much agricultural land, so that's difficult for that. Okay, so just I show you the another example for the another region, which I just a minute, I show you that. Okay, as well as so you can simply go to this link for the band combination. They are provide the example about with the band combination. So band combination for Landsat 8. So simply go to this link. So here we can get all of this information about the band combination with their example. So here you can see, and also read the article. You can suppose you can see natural color. It's called the 432, and this is the human eyes what can see. Okay, also color infrared. In this time we can get the vegetation, this type of red color. Then I use here the 543, as well as also you can see the short wave infrared agriculture 652. When I use that, so in this time I can get this type of structure. Okay, suppose a square or rectangle, this type of structure I can get. Okay, but when it will be vegetation or forest, then it will be not maintain the sequence about this type of structure. I did not find. I can get the green pixel value, but it not maintain the structure. Suppose a square. In this time, you can see this is the square or rectangle. This type of a square we can get. Also, you can see this is square. Also in the square. Okay, I can get the shape about the agriculture land. Okay, then I can simply collect the training point from here as the agriculture land. Okay, but when I get in this time, you can see for this region, I did not get any types of structure. Okay, so it is a vegetation, but it not maintain the structure. Okay, so that's why it's a vegetation. It can be other types of trees or other things, but not this type of shape. So that's why we did not say about this a vegetation or. But when it will be agricultural land must have the structure, a square shape or other types of specific shape. From the we can easily identify about that. Okay, so now using this type of band combination, as well as also other band combination also available, you can see for the geological structure we are mainly use at that 762. When you want to identify the geological feature, use this band combination. A bathymetric, you can also use at the bathymetric 431. We can easily identify the bathymetric feature, and it's good for estimating the suspended sediment in the water. Okay, we can easily identify when you use the water body, you can apply about the 431. Then we can easily identify the estimating the suspended sediment in the water body, pancometric. Okay, as well as for the ndvi. So this is the another types of index. Okay, basically it's the equation. We need to apply the equation for identify the vegetation, and how we can easily use this type of index. I already show you that for our previous class. ndvi, also moisture index. Okay, so you can also follow this link, then you can easily get all of this information from here. Okay, so now we are using here the different band combination and then collect the training point. Okay, so now how I can collect the training point. Okay, so let's go. We collect the training point. So for collecting the training point, we can use the different approach. If you want, you can use the marker for collecting the training point, or if you want, you can also use at the rectangle. Okay, use the rectangle shape and collect the training point. But it's also possible just use at the marker, because when you use the rectangle, then it has also take lot of pixel value. Okay, and when it will be across the limit 5000 element, then it will be not work. Okay, so for that it's safe, you can just use at the marker and take the training point. So just I simply use the marker, you can see geometry will be added in here and also add in here. Okay, then click on here the setting button, and I put the name. First of all, I put the name. So I put the name, suppose water. You can use any name, water. And then feature collection, input property. I set the property name such as class. Property name you can put anything, there is no problem. But property name is the same for all of those class. Suppose when I take the training point for the vegetation, property name will be class. When I take the training point for the barren land, property name will be class all time. And I set the water 0. Okay, I set the water training point as a 0. In this time, when I take the training point, suppose I take the one number of training point, this value will be 0. I take the another, this value is also 0. So all of this training point value is the 0. Okay, and 0 is the number. Okay, this number identify it is the water training point, or it is a pre-categorized data of water. Okay, so basically it is supervised. So that's why I need to create the label data. Okay, so in this time I set the label for water is a 0. Yeah, please.
Can I use any number instead of 0 or only 0?
Okay, we can start the sequentially 0, 1, 2, 3. It also better, but you can use any number. There is no problem. Okay, but you remember that what's the class you want to use for this number. Okay, you can use any number. There is no problem. But remember that I use the 0 for water body. Suppose you use the 10. Suppose you can just remember the 10 I use for water body. And how much training point I can take? Okay, for here, for every classes. So mainly it depends on our accuracy. Okay, so when I check my accuracy, this accuracy is not acceptable, then I also need to increasing or decreasing my training point. Okay, So before, first of all, we have to check our accuracy, and then when I can get the suppose I did not get the better accuracy, then I need to increasing or decreasing that specific training point. Then it also, when I can get the better accuracy, then it will be fixed. That is no problem. But take the training point more than 50. It also better for the take the training point as a more than 50. Okay, and then let's take the another training point. Suppose vegetation. Click on here and click in here again. Edit later properties and set the value such as in this time. Suppose vegetation. Use at the vegetation and import as feature collection and property. Property will be same class and set the value for vegetation 1. Okay, so in this time all of those training point for vegetation will be 1. So in this time we can get the two type of vegetation, but I just use at this all of those vegetation consider as a one class. Okay, so just I simply take this training point for the vegetation. And in this time, you can also get the satellite view image. So it also provides the Google satellite. So that's why we are also zooming about our place. And from here, we can easily find out the result from here. Yeah, I think it's the agricultural land. Yeah, it's the agricultural land. Okay. So in this time, you can see this type of land is the agricultural land in here. Because you can also compare this result from this map. Simply zoom. Yeah, agriculture, you can see. So agricultural land, okay, you can get the structure as a shape structure. So in this time, this type of bright green identify the agricultural land. Okay, so in this time I not classified the agricultural land, so all of the vegetation consider as a agricultural land, or other times I consider as a vegetation. Okay, so this type of identify the agricultural land. Okay, and we are also using this type of base map, satellite base map, to sure about that what is that. Okay, so in this time, all of those bright green in this region, all of those bright green identify the agricultural land. Okay. So suppose you want to classify it also agricultural land, then you have to take the separate training point for the agricultural land and also take the other vegetation. You take the other training point. Okay. But in this time, we can just simply combine agricultural land and also vegetation, same class. Okay, done. So in this time, I take the another training point such as barren land. So just click on here and click on this again, barren land or flow land, and then feature collection, property. Property will be class and set the value for 0, 1, 2, 2. Okay, so 0, 1, 2. So in this time, we can get the two types of fallow land. One is the wetland, and another thing is that barren land. So in this time, I consider all of those land, fallow land is the one classes. Okay. Okay. So now take the another class such as build up. Click on here. And input as feature collection. Property will be class. Set the value for 0, 1, 2, 3. Okay. So build up video we are using as the natural color, that is the better. So use here the red, green, and blue. Okay. So now we take the turning point from the build up area. Okay. So I take the turning point, look like that. Okay, so here I can get all of those training point in here. So this is my third step for collecting all of those training point for water, vegetation, barrel and build up. Okay, so now I move to the fourth step is that.
So,
Yeah, please.
excuse me.
Yeah,
If I collect the ground truth data,
yeah.
so how many
Okay. Okay.
points
For the ground
response?
truth data, we have to import the data set. Okay. For the ground truth data, you can see here the CSV file. Okay. So in this CSV file, suppose you want to collect the training point for the agricultural land. So mainly when you want to classify the agricultural land, different types of crop must be need the ground truth data. Okay, you can simply collect the sample specific coordinate latitude and longitude. Okay, and also set their for the class. Okay, for that simply you can simply import this file latitude and longitude, and after that we have also need to write here, you can see your column name, x column and y column. X column is the longitude and y column is the latitude. Simply put your column name, your excel file column name. Okay, suppose in your excel file you can simply import any excel file. Suppose import your excel file look like that. Suppose this is your excel file. In this time you can put here that let and put here the suppose month. In this time you can put your specific, suppose let long you can put the value for a specific feature, suppose agricultural land, you can put your specific value and then simply import it in Google Earth Engine platform. You can simply put here the let and also put here the long. Okay, same name, same column name you need to use in here, let and long. Another thing will be same, and then simply upload that. Okay, then it will be work as a point shape file in your you can easily display the point shape file, and then you don't need to collect the training point look like that. After uploading that, you have to just, or when you can simply click on here, suppose just a minute, click on here CSV, and you can also set the metadata. You can see add property. Okay, add property, click on here, and then you can simply set the property name. Suppose it's my property name will be class, you can put any name and set the value, suppose 0. Okay, then click the upload, so then it will be uploaded. Okay, So in this time, I did not use the ground truth data. So that's why I can simply click on here and then simply imported physical and select my property and value name in here. Okay, because in this time I don't use the ground truth data. But when you use the ground truth data, first of all, you need to create the CSV file, a specific feature with their coordinate, latitude and longitude. And after this, simply click on here and go to the CSV file. Simply select your source file, give a name, any name you can put, and then simply you can see the column name. Just use here the column name, which column you can write in your Excel file or CSV file, column name. After that, you can simply set the add property, and after add property, simply put your property name. You can use any name, class, and set the value for a specific, suppose 0 or 1, 0. Then upload it. Okay, so in this time we are not using that, so that's why you can take the training point from the satellite images. But it also possible to use the ground truth data for making the land use land cover classification map. And mainly land use land cover classification ground truth data need when you want to identify the specific crop types. Okay, suppose sugar cane, rice, maize, this type of crop classification. When you want to need, you must be need the ground truth data. Okay, and also ground truth data need for the validation. Suppose you can simply go to the your ground field and then simply take the GPS location, and using the GPS location you can simply validate your result. I create the land use level classification, so now I want to validate my result using the ground truth data. So it also possible, same approach for that. Okay, any question?
So how about the pre-categorized data?
You can pre-categorize data means that in this time you can say set the property. Okay, you can see I set the property. I can set the property also in here. So that's why it will be pre-categorized. Suppose I take the 10 training point in my Excel file. I just simply put the property, it will be class. And suppose I take the training point for the water body. All of those water body I consider is a 0. Okay, so now it will be pre-categorized as a 0 for the water. Suppose then you also try to import the another class, another ground truth data for water body, same approach, and then put here the suppose water body 1 and upload that. Suppose vegetation, put here the 2 and upload the vegetation. Suppose put here the build up area, put here the 2
Okay,
and upload that.
so every class will be stored in different what?
Yeah, different file, yeah, different, yeah, different file you need to import that. And every time set the value, okay, for the 0 to 1 to 3 like that. Simply set the value. So in this time we can, which I do in here, just same process, put property and value, all of this will be same, and it will be imported as a point shape file. In this time all of those training point as a point shape file which I created. But when you want to import this type of CSV file, it also considered as a point shape file or point. Okay, okay, so now I take the training point, all of those things training point I can collect in here. So now I just need to merge. Okay, for merge means that I need to store all of those training point in a one variable. So for that, merge a variable. Suppose I put the variable as a sample. You can use any variable name. In this variable I merge all of those training point one by one. First of all, water, it merge with vegetation, it merge with barren land, merge with fill up. Okay, so now it's merged. In this time I want to check how much training point I use. So use the print function and print the samples, this variable. Click to the run. In this time it display the result. You can see feature collection 236 training point I use total for all of those classes, and all of those class, all of those training point already pre-categorized. You can see here, suppose suppose this training point, what is the class I want to check. Click on here and click the property class 1. Okay, class 1 means that it is the vegetation. So this training point I pre-categorized for or labeled for vegetation. So all of this training point is already pre-categorized. Click on here. You can see what is the training point, class 2. So this training point I use for barren land. Okay, so all of this training point is already pre-categorized. So that's why it's called the supervised machine learning method. But when I do for that unsupervised, then I don't need to create any types of pre-categorized data. Just I use here the clustering and find out the similar properties of pixel value. Okay, just take the similar characteristics of pixel value and make the classification. Okay, so I'll show you that later. So in this time here I can get the all of those training point look like that. Okay, so in this time I just need to extract the band pixel value. Okay, all of the training point I just need to extract the band pixel value. In this time, which band you want to use in here? Okay, so here you can see mainly the total all 7 band: B1, B2, B3, B4, B5, B6 and B7. Total 7 band is available. Okay, so in this time I want to extract the band pixel value, total 7 band for each training point, mainly total 236 training point, extract the 7 band. Suppose this 0 number training point extract the pixel value B1, B2, B3, B4, B5, B6 and B7. So all of those training point extract the band pixel value. Okay, and it's my data set. Okay, so further use the data set, I need to train my model and then classify the image. Okay, so let's go. So how we can easily extract the band pixel value? So first of all, I need to create a variable bands. In this variable, I store all of those band which I need or which spectral signature I need to create. So use the SRB1, SRB2, SRB3, SRB4, SRB5, SRB6, and finally SRB7. Okay, so just I select my band name. In this time, all of those band pixel value I extract for all of those training point, total 236. Okay, so now how I can do that? So for extracting the band pixel value or a spectral signature, just I take a variable. I put the variable name, suppose training. You can put any variable name. I put the training. And first of all, I call my image. Okay, so basically this is my image. Okay, from this image I extract all of those band pixel value or spectral signature. Simply copy the image and paste here. And from this image I just use a function select all of those band. Okay, and all of those band is stored in a variable which are bands. Simply copy the bands and paste and use the function, this function called the reduce regions. Okay, so we already discussed about the reduce region function. In this time this function will be reduce regions. Okay, extra s we need to add in here. Okay, so in this time what happened? So mainly this function extract the pixel value from a collection. In this time it's my collection. You can see feature collection, total 236 point in here. I have to extract the all of those training point or all of those point, extract the pixel value. So that's why I use the reduce regions function. So this function mainly help to extract the pixel value from a collection. So just I use here and then put all of those argument. So make a dictionary. So curly bracket start. And also curly bracket in here. So first of all, collection. Collection means that your training collection. Total 236. It is stored in this variable samples. Simply copy that and paste here. Reducer is at EE dot reducer mean. Then scale is the 30-meter resolution. And then import all of the .NET in this time. So now I simply print that training, then click run. In this time, it create the training data set. Click on here, feature. In this time, I can get the, you can see 8 properties. So click on here and properties. Here I can get all of those pixel value about that for the 0. All of the training point, extract the band pixel value, a specific pixel value, extract from here. And this is my data set. Okay, this is my data set. Okay, so now this data set I need to use and then further analysis for create the model. And after creating this model, I just make the classify. So now my data set is ready. Okay, so now in machine learning method, when you want to create the data set, after creating the data set, this data set you need to divide into 2 ways. So some data set we need to use for train our model, and also some data set we need to use for test our model. Okay, so in this time here I can get training. It is stored the full data set, all of those data set. So this data set I need to separate or split into 2 ways. One is that some data set I use for train my model, and some data set I need to use for my test my model for checking the accuracy. Okay, so mainly there are a lot of way for the split. So for that we can use at this, suppose sometimes 70%, 30%. Okay, also sometimes we also use for the 80%, 20%. Okay, suppose 80% data I use for train my model, and 20% data I use for check my accuracy about this model. Okay, so now this data set I need to separate or split in the 2 way. So first of all, for that, and I do it randomly. Okay, not selectively, I do it randomly. So for randomly, when I do that, first of all, this data set training, this data set I need to create the random distribution. After that, I need to collect the 70% data or 30% data or 20% data, 80% data or 20% data. So first of all, this data set I need to create the randomly distribution. For randomly distribution, I need to use a function, take a variable. Suppose I put the variable name is that suppose training data set. Okay, so simply copy the training, and now this training I need to distribute it as a randomly. So put here the function random okay, so random random column. So use the random column. So now this data set randomly distributed and stored in this variable. Okay, so now this data set I need to split the 2 way, 70% and 30%. Okay, so just I put here the train set. I use the train set 80% and suppose test set 20%. Okay, so after that simply take a variable, suppose train set and call this training data set.